Okay, so this lesson is a little bit different than what we've been doing. We're starting a new unit, and our new unit is going to be about circles. It's going to just be a whole bunch of circle stuff. And this is really kind of our last unit of geometry. It's going to cover a couple chapters that would be in our book. I'm just going to use a different resource that isn't our book. So for this lesson, you guys are just going to purely take notes on our vocabulary. I'm designating this week just to vocabulary because it's so important in this unit to set that foundation before we start the unit. Because there's a lot of vocabulary terms that you're going to have that you didn't use before. Now I'm going to do a couple that you probably know, but you need to know the math definition for it. So you should have a piece of paper out and you should be writing down every single thing that I write down today. And part of your grade for this week is doing that, taking a picture of it, and sending it to me. So I would just get a piece of paper out right now if you don't already have one. Okay, so I would make something that looks kind of like this. That's just a vocab sheet, and you'll see how on the right-hand side I have a circle for each of them because we're going to draw what this actually means on a circle so you guys can go back and look at this. So first of all, a circle is the set of points equidistant from a given point. Which is the center. So we are going to say that P is the center and that a circle is made up of these points, infinitely many points that are equidistant from P all the way around. This is just the formal definition for a circle, so go ahead and write that down and draw your picture. Now, radius is one that you should know. A radius is a segment with endpoints at the center oh, excuse me. And on the circle. So if we have our center P again, and I have a point A on the circle, PA would be a radius. Now a chord is a new one, and you're going to have to do a lot of stuff with chords. So this is kind of part of the reason why we're doing this. So a chord is a segment with endpoints on the circle. So it does not have to go through the center. So here, J, K would be a chord. So it's just any 2 points that are connected, and those 2 points have to be on the circle. Your point or your line does not have to go through the center. Okay, so a diameter is a chord that does pass through the center. So a chord that passes through the center. So we are going to go ahead and draw that. So P is the center, and we're just going to name this A, B. A is the diameter. If you guys need an easy way to remember this, I always remember for radius and diameter that diameter makes a D. Radius is only half the circle, so it doesn't. So I just remember diameter makes a D, and then you will never confuse them. Okay, so now a secant is a line that intersects the circle at exactly 2 places. So I'm going to draw a line. And it intersects at exactly 2 places. It does not need to go through the center of the circle. It just intersects it at exactly 2 places. So a tangent, which if you guys ever get to calculus, you're going to use tangent lines a lot. That's basically what all of calculus 1 is tangent lines. So it's a line that intersects the circle at exactly 1 place. These are kind of hard to draw, actually. That's actually pretty good. So you can see it actually only intersects right there because those other points next to it are going to move off of that line. So we're just going to put a couple points on here. P, R would be our line that is a tangent line, and Q is our point of tangency. So that's our next one. So we have a tangent line. The point of tangency is exactly where that tangent line touches the circle, in that one exact spot. So a tangent line, or point of tangency, is the point at which the tangent line intersects the circle. So I'm going to draw the same thing again. Our point of tangency is Q. Okay, now a central angle is an angle with a vertex at the center. And 2 sides that are radii, which is just the plural for radius. So we have the vertex at the center, And PA and PB are each a radius. So the two sides are radii. An inscribed angle is an angle with a vertex on the circle and two sides that are chords. So remember, a chord doesn't have to go through a center or anything like that. So we're going to have this vertex. I'm going to label it C. And we're going to have A and B. Now this is an inscribed angle because CA and CB are each a chord. So chords, remember, are not diameters, they're not radii, they're not anything like that. They just intersect at 2 points on the circle. So an inscribed angle and a central angle look very similar, but you have to pay attention to where the vertex is at, and that's going to be super important to make sure you know the difference between those two. So an arc is a portion of the edge of the circle defined by two endpoints. And we have a new symbol here. So symbol, and it looks like this. So when we do this, I'm going to label this A and B. I'm going to do this in a different color so you can see it. Okay, so AB, to say that is an arc, we just put that little symbol over top of it. So that would mean arc AB. That's super important to have that notation. You have to have that to say that it's an arc. You're going to see that a lot in this unit. Now, a minor arc is an arc with a measure less than 180 degrees. And there's one key I want to point out. So with a minor arc, you use 2 letters to name it. So I'm just going to do another one. And label it CD, and that would be arc CD. 180 degrees is just half a circle, just so that you guys know. Okay, now here is how a major arc is different. A major arc is an arc with a measure greater than 180 degrees. And there's one big difference. You are going to name it with 3 letters. So, Okay, so if I look at this, I have ABC, and I'm going to say it's arc ABC. And the reason why we use 3 letters is because when we are naming these, we always assume the shortest distance. So if I said arc AC would actually be this arc, which is not what we wanted, right? So make sure you don't draw that one on your paper. Just have your major arc on there. Now, a semicircle is an arc with endpoints on the diameter. And it always equals 180 degrees. This is another case where you have to name it with 3 letters just because there is no shortest distance to take. So we kind of need to know which side it is. So I'm going to say the center is P. So we are going to say this is arc JKL, and that would be a semicircle, which is just half of a circle. Now, the last thing we're going to do is write down a couple of formulas that you're going to have to use pretty frequently in this unit. Please make sure you have these written down. This is part of what you have to turn in. So our area is going to be pi times r squared. And remember that r is your radius. You should already know how to use this one because you went through it in 7th grade math and then used it again in 8th grade math. But just a reminder, the circumference is 2 pi r. Remember that r is your radius. Or you can do circumference equals pi times diameter. D is diameter. And the last one, which is arc length, is new for you guys. You have not done arc length before. So arc length, we're going to denote with just an L, a cursive L. And we're going to say it's x times c over 360. Now x is the degree of your arc, and c is your circumference. So that's kind of your new one that you need to know. The others should be kind of a review. This is everything for this week, you guys. All you had to do was copy the stuff down for this video. And then this isn't the whole worksheet, but this is the worksheet that you guys are going to do for your homework. Now, the 2 things that you have to turn in to me this week to get a grade are a picture of your notes with all the vocabulary written down in the formulas, and then this worksheet completely filled in. This one doesn't have it, but your guys's actually has letters on the side, so it'll say like A, B, C, D. You get the hint. So if I look at LQ, if I extend this, has a point of tangency here because it's a tangent line. So this would be E, F. So on your guys' paper, instead of writing tangent with 1, just write F. And when you go ahead and go to turn this into me, you're obviously not going to have this probably print it out. If you do, that's great. But if not, just write 1, 2, 3, 4, 5, 6. And then with 1, you would write F. And then so on with all your answers, all the way to the end. Just because it's going to be easier for me to look at it and tell you, hey, look at these ones again. That's a little different than what it's supposed to be. If you look at this first one that I did with you guys, see how I extended that line? It just makes it easier to see it. So you can see that that's a tangent line. You might have to do that with some of these just to be able to see what it is. If you look at SRT or just ST, you can see that's also a tangent line and they have the whole thing drawn for you. But with LQ, that one's a little tricky. That's still a tangent line. The other thing is you should read the directions. It says this in the directions. But you can use more than one of those parts of circles, or you can use those parts of circles more than once. So ST was also a tangent line, so 6 would also be F. So go ahead and do those two things and turn them in to me. You'll just send them to me in an email. And that's all you have this week. You don't have an actual quiz. So as long as you do them, you get all of your points for this week. So that's super easy. If you're missing other stuff from the online stuff, or if you're missing homework from quarter 3, go ahead and do that stuff this week because you really don't have that much to do this week. So email me and let me know if you have any questions, and make sure you email me your assignments.